So this is number 11 on the second handout. The triangle sum one. When you look at this, you're going to try to find the ones that are easiest to find. So when I'm looking at this, I see that I have 71. It is vertical angles with number 2. All right, so I'm going to immediately solve for number 2 first because I really don't have to do anything to solve for it. 71 is number 2. That actually helps me solve for 3 and 5. Why does that help me solve for 3 and 5? Why does a 71 also help? Yeah, it's a linear pair with 5. It's a linear pair with 3. So if I say 180 minus 71, I'm going to get 3 and 5 because they're actually the same angle. So if I have 71 here, that's going to give me 3 and 5 because it's a linear pair to 3, and 3 is congruent to 5 by vertical. So if I subtract these, I'm going to get 109 for 3 and 109 for 5. So as you solve these, you're going to solve the ones that are easiest. Solve the one where you don't have to do anything at all. Use the linear pair to solve for 3 and 5. Now from there, that's actually going to help me solve for other angles. So if I know then that this is 71, I can use the triangle sum theorem for 47, 71, and 1. Those should add up to 180. Okay, so I can now solve for 1. I can just say 180 minus 47 plus 71, which is where I am going to get the 62. All right. Because I also know that this is 109 and this is 109, I can solve for 4 and I can solve for 6 using the same method. So measure 4 is going to be 180 minus 109 plus 36. And then the measure of angle 6 is going to be 180 minus 109 plus 42. All right? So questions on those? So at this point, you should also have 4 and 6. 4 and 6. All right. Now they are using, so an isosceles triangle, we already know the definition of the isosceles triangle. We know that the two sides of the isosceles triangle are congruent. All right. These two congruent sides are called the legs of the triangle. And the angle that is at the top is called the vertex angle. So if I have the legs of the angle right here, my vertex is going to be this one. So the orientation matters. If this were laying on its side, that would still be the vertex, even though it's not at the top. All right, so orientation, you have to pay attention to where the legs of your isosceles triangle are. So it's just like the legs of an angle. So the legs of the angle make up the vertex angle. So the legs of the isosceles triangle makes up the vertex angle. The side opposite of the vertex angle, so they're talking about the side that is opposite of that vertex, is called the base of the isosceles triangle. And then those angles that make up the base are called the base angles. All right, we have some theorems here that again you're going to use when we get into proofs. The isosceles triangle theorem says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So what are they saying? Well, what they're saying here is that if AB is congruent to BC, which we see that it is based on the notation, then angle A is congruent to angle C. So this is basically telling that your base angles of an isosceles triangle are congruent. So the isosceles triangle theorem says that if you have congruent sides or an isosceles triangle, then your base angles are congruent. So then the converse of that tells us that if two angles of the triangle are congruent, then the sides opposite are congruent. So these work both directions. If I have congruent sides here, then I can assume that the angles opposite of those sides are congruent. If I have congruent angles, I can assume the sides opposite of those angles are congruent. So if A is congruent to C, then the side opposite is congruent to the side opposite as well. So they've told us that they've only given us one angle in this triangle. Normally to solve for another angle, we would have to have at least two because they add up to 180. But this is a special type of angle triangle. This is an isosceles triangle. So if they've told us that this is 68 degrees, we can see that these are the legs, which means these are the base angles. Then I can assume, based on the fact that these are congruent, that J is also 68 degrees. And since I know these two are 68 degrees, then I can go back to my triangle sum, and I could say, well, 180 minus those 68 degrees is going to give me my vertex angle of 44 degrees. All right, so it helps you then solve for all the angles when you know one of them in an isosceles triangle. So for this next one, they've given us the vertex angle. They've given us the vertex. So then how then would I solve for the base angles if I only know the vertex? So I know that all three of them add up to what? 180. So I'm going to say, well, 180 minus 106. 180 minus 106. What is 180 minus 106? All right, and so then if I have that is 74 degrees, that's going to be both of these together, right? Does that make sense? So if both of them are 74 and they're the same, how am I going to solve for one of them? Both of these angles add up to 74 and they're the same degree. Yeah, I just did it, divide it in half, right? And so we know that both of them are 37 degrees. Both of those are 37 degrees. So go ahead and do number 3. All right, look at the next one. It says find the value of each variable. All right, value of each variable. So they have told us that we have congruent sides. We know we have an isosceles triangle. Because these are congruent, the angles opposite of them are also congruent angles, which means these are congruent. So if I'm solving for this variable and I know they're congruent, I'm simply going to set them equal to each other and solve. All right, so you're going to get your variables to one side, your numbers to the other. So 39 equals 13x, so, or sorry, 3x, I'm jumping ahead. X equals 13. All right. So you can use your knowledge of an isosceles triangle to then solve for a variable. So go ahead and do number 5. Just like we did yesterday, they can give you the description as well, and you can find what you need to find based on the description. It says if RST is a triangle, so they give the triangle RST, and you have RT congruent to ST, that automatically tells you that two sides are congruent. And then they give you the measure of angles. Find X and the measure of each angle, okay? And so based on this, I have R to T and S to T. I actually know that I am going to have a triangle that has R to T and S to T, okay? So R to T and S to T. And so you want to draw a triangle based on what they give you. If you know your RT and your ST are congruent, those are your legs of your isosceles triangle. So then we know that the measure of angle R is 9x plus 2. The measure of angle S is 13x minus 18. And then the measure of angle T is 17x plus 1. If I want to solve for x and then all three of my angles, the easiest thing to do here is to set those two at the base equal to each other. So I'm going to say 9x plus 2 equals 13x minus 18. Move your variables to one side. Move your numbers to the other. And then solve for x. And so we automatically have our x equals 5. They want all three angles. So I'm just going to plug it back into one of my base angles. It doesn't matter which one. I'm going to say 9 times 5 plus 2. That is R. Well, that's going to give me 47 degrees. I don't even need to plug it into the other one because I know that S is also 47 degrees. And I can solve for T two different ways. I can either plug 5 in, 17 times 5 plus 1, or I can just say 180 minus my two base angles added up. Either way, I'm going to get 86 degrees for my measure of angle T. So once you have one of them, you really can find the others just by knowing they're congruent and using your sum of the angles equals 180. So go ahead and try number 9 there. They told you that D was congruent to E. That told you those were your base angles. So D and E had to be your base angles if they were congruent, which means your vertex had to be F. So then that means DF should be congruent to EF. So you should have set the DF and the EF equal to each other to solve for X. And then once you have that, you can plug it back in to solve for your side lengths. They were asking about side lengths here. EF and DF should be the same side length because those are your legs. And then E, you just plug it back in for DE. A triangle is equilateral even if and only if it is equiangular. All right? So if the measure of A, B, and C are all congruent, then that means your sides are all congruent. And vice versa. If your sides are all congruent, then your measures of your angles are all equal. So then in this case, if they give me one of the sides, I automatically know my other two sides. And if they give me two of the angles, I automatically know my third angle. That's how it's going to work. They told me on this next one, all three sides are congruent. How then do I know what my angles are if they didn't give them to me? All three of my angles are also congruent, right? Yeah, why does it have to be 60? Because they all add up to 180. If this guy is X, he's going to be the same thing, and he's going to be the same thing, right? They're all the same angle. So if I give it a variable, I can give it all the same variable, which means X plus X plus X should all equal 180, or 3X equals 180. In an equilateral triangle, my angles must be 60 degrees. That's the only way it will work. It's the only three angles that are the same that add up to 180. Mathematically, that's how it has to work. Congruent triangles have the same shape and the same size. Congruent triangles have the same shape and the same size. All right? This means all corresponding parts, the angles and the sides, are congruent. So all congruent triangles have the same shape and size, which means their angles and sides are congruent. Their angles and sides are congruent. So let's look at this congruent statement. This is very important. Order matters here when you're talking about congruence. If I have angle A with this little mark and angle D with that little same mark, it means that angle A is congruent to angle D. And then you'll notice that B has two little arcs on it and E has two little arcs on it. That means B is congruent to E. And then you'll see that C has 3 of those marks and F has 3 of those marks. It means that C is congruent to F. Okay? So when I list this congruent statement, if A is first, whatever A is congruent to has to be first in my next one. If B is second, then whatever B is congruent to has to be second. And if C is third, then whatever C is congruent to has to be third. So it doesn't matter how you write the first guy as long as the second guy corresponds to it, okay? Order matters because when you write that congruent statement, this statement right here is actually telling me which parts are congruent, okay? The way you write it tells me which ones are congruent to each other. And so the order matters, and you will miss it if you mess up the order. So if I ask you to tell me what's congruent and you do it in the wrong order, you're going to get it wrong because you're telling me the wrong parts are congruent. Which leads us to this next piece. You're going to use this with proofs as well. CPCTC is an abbreviation for corresponding parts of congruent triangles are congruent. Every corresponding part of a congruent triangle is congruent. All right, corresponding means the parts that go with the other side based on the order that they have been written in. Corresponding parts of congruent triangles are congruent. In your proofs, you're going to see it abbreviated with this, just so you don't have to write it out every time you use this particular theorem about congruent triangles. But that's what it means, that the congruent parts, the corresponding parts are congruent. They have given me this congruent statement. Triangle JKL is congruent to triangle PQR. List all the angles that are congruent. Well, I'm going to say that angle J is congruent to angle P. Angle K is congruent to angle Q, and angle L is congruent to angle R. For side lengths, I'm going to do the same thing in the order. So I have JK should be congruent to PQ. KL should be congruent to QR. And then JL should be congruent to PR. All right, so I just line up the pieces that are congruent, which will help me if I need to draw a triangle. So if I were to have to draw these two triangles to try to sketch and see what's going on with them, I can do it based on the congruent statement that it's given me. It says, write another valid congruent statement. Well, another valid congruent statement would be to write this in a different order. So if I were to say triangle KLJ, then I should say that that is congruent to, if K was congruent here, it's congruent to Q. L was next, so then R has to be next. J was last, so then P has to be last. All right, so you can write them in whatever order you want as long as they line up. As long as they line up, it doesn't matter what the first order is in. So this statement right here and this statement right here tell me the same exact thing. All right, so go ahead and do number 2. Give me the angles, the sides, and write one more congruent statement. So we talked about special types of triangles, isosceles and equilateral. In this case, they're just telling me two triangles. So we don't know that within the triangle we have any special relationship. What we do know is between the two triangles that we have congruence. And so I would tell you that if you have a handout or if you have a test or a quiz, you may want to incorporate color here. If you have colored highlighters, it's a good place to start highlighting and making them in color. Because what they're telling me is they're telling me some congruence information. They're saying that UVW is congruent to TSR. So in this case, I'm talking about sides. So that means the side UV should be congruent to the side TS. The side VW should be congruent to the side SR. And the side UW should be congruent to the side TR. And so you'll notice the orientation doesn't exactly match up. So you can't just look at it and say, oh, this looks like these sides are congruent. You literally have to read the congruent statement. You have to read the congruent statement. So I know that 12x minus 7 should equal 53. I know that 5y minus 33 should equal 57. And I know that 3z plus 14 should equal 50 because of the way that they have given me that congruent statement. And so it's important that you line them up so that you know which ones to set equal to. And then you're just going to solve like you would. Add your 7, divide by your 12. And you're going to do these just like you would solve any algebra. And you can solve for all of your variables there based on the congruent statements. So if you have highlighters or colored pencils, this is where you'd want to make sure that you are lining them up correctly. So go ahead and try that next one.